Hopefully, I am in live. Let me check. Hopefully, I am in. Okay. இன்னைக்கு எதை பற்றி பார்க்க போகிறோம்னா zero knowledge for zero north, but why? This is $1 million question. ஸோ கோடிங் குள்ளெல்லாம் போகிறதுக்கு முன்னாடி I need to give some context. Maritime industry-ல when you're dealing with bunkers, the bunkers-னால் வந்து it's like a petrol bunk for ship. ஸோ ஒவ்வொரு போர்ட் அத்தாரிட்டியுமே they need to provide some legal compliance, legal documents submit பண்ணணும். So one such legal document is the sulfur content in a fuel. The sulfur content should be less than a limit. It depends on the port. Okay. So what I created is I have already created the contract. This contract is a multi-party contract which involves two parties. The one is the bunker node, and other one is the chief engineer in the shipment. So this was my old contract. It does not have any zero knowledge. Here you can see the sulfur amount is publicly available. Anyone can look into the sulfur content. Of course, in an enterprise, most of the blockchains is going to be private, but still it is viewed by both the parties and also by the port authorities. And also the sulfur content may be some sensitive data when it comes to handling the business, maybe, I'm not sure. So my solution is we can prove that the sulfur content is within the limit without revealing the actual sulfur content of the fuel. So crazy, right? Yeah, this is not just for the sulfur content. This can be done for any of the parameters or any of the criterias that requires the port authority to verify. We can generate a proof using the zero knowledge and verify using on-chain verification contract. That we will go through it, like what are the process involved in zero knowledge. We'll go through it. Before that, I just want to give you an overview of how the contract was, and then we will go to the zero knowledge part, right? Okay. Actually, this contract has two important functions. One is the bunker, nominate bunker. Okay, so what nominate bunker, this is the first step, the initial part. This should be initialized by the bunker tankers, right? So they pass the delivery ID. IMO is a unique number for the shipment. Supplier ID is the bunker node's ID, and then the exact sulfur. So this is in the first version. I have mentioned the exact sulfur, but in the second version where I have implemented the zero knowledge, I have not mentioned this exact sulfur. I don't want to make this as a public. So rather we are going to prove that the exact sulfur is within the constraint without revealing the actual sulfur as a public parameters, right? So inside this bunker node, we are just checking whether the state is none, and then we are updating our other parameters, making sure my charges. I need to charge my app. Give me a second. Okay, so we have to make sure that the state is none, and then we are going to update the other parameters. This bunker node will return as the node, the bunker node. So this is the mapping between the delivery ID as well as the struct. Here you can see the bytes 32 and then the bunker node. This is the bunker node. Fine. And then it emits the event, and this finalized bunker is the very important function. It takes two signatures of signature for the supplier and signature for the CPU engineer. So this is the digest, the message hash. With this message hash we are using message hash utils to get the digest, and then From the signature, we're going to recover the signer's address and making sure this both the player as well as the chief engineer has been registered already by the admin. So here are the two functions used to register both the supplier as well as the chief engineer. And once verified, we're going to update the other parameters, which happens after the fuel is transferred from the bunker to the ship, and we emit the event. And this is very critical function. I have implemented the MLDSC, the quantum resistant signature verification, uh, where we produce this PDF hash and as well as the quantum signature option, and we anchor both of them on the blockchain by calling this anchor quantum seal, which takes the PDF hash and then the quantum signature. Make sure like the bunker state is finalized. After calling this finalized function, the state has been updated to the finalized, and we update the other parameters and we emit the event. And this is the verify functions which does the same thing of the finalized bunker. So I will provide you the GitHub link where you can go through this code or contract by yourself. But today we're going to speak specifically about the zero knowledge, right? And particularly the sulfur content. So in this case, the sulfur content is publicly available. Both the parties can see, and also it can be seen by other entities who participate in the blockchain, and 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 most of the port authority requires the sulfur content should be less than the constraint, so they want the exact parameter. So what if we can create an ecosystem where we can prove certain things without revealing the actual parameters, like maybe it can affect the business, or it is very sensitive data that no one wants to reveal it, the business wants to keep its secrets or secret, something like that. So I developed a circuit in Noah, a programming language. It's a domain specific language, it's very small. This is very similar to the Rust programming language. So it takes two parameters, one is the sulfur limit and then the sulfur content, right? And it checks whether the sulfur content within the sulfur limit. Here you can see the sulfur content uh, is the sulfur content that's present in the fuel that's been transferred between the bunker node and then the ship. So this is the private. By default, the parameters in the Nova programming language is private, so you have to make it public, we have to specify the pub keyword. So in this case, the sulfur limit that's been authorized by the port is being set to the public, and then we just check using the so this is the circuit, and then we have to generate the VK, it's a verification key. With this verification, we're going to generate the verifier contract. So this is the contract that's been deployed to the blockchain, and this is the contract that we use to verify the proof that's been generated from the circuit on the blockchain, right? So let me go through this updated contract. So all of the functionalities are same except for one thing. In the bunker node, we don't no longer have the sulfur content. Rather than that, inside this nominate function, instead of taking the sulfur content, we are taking two things, two parameters. One is the proof and then the sulfur limit. So this I underscore verify function dot verify function, inside this verify function takes two parameters, the proof which we generate from the circuit, and then the public inputs. So in our case, the public input is going to be the sulfur limit, right? Which has been authorized by the port managers or port authorities. So if this verify successfully, then we are going to move on with other procedures that we have followed in the previous contract. So this is the only change that we have made. Okay, so you may have the doubt like how do you test it, like using the FFI in the foundry we're going to test it. So npx txx, I have created a JavaScript TypeScript file, generate Nova proof, which takes two parameters, both the public as well as the private. So this is going to be the private parameters, this is going to be the public parameters, and which is going to return the proof that's been encoded. So we have to decode it over here. So we'll go through what is this TypeScript function does, right? So it's going to slice the first two parameters, and we're going to check. After slicing, we have two parameters, one is for the sulfur content, another is for the sulfur limit, and we're going to initialize the Beretenberg, Noah, and then the backend honk. So this is the one that is used for producing or generating the proof, and the Nova is used to uh, generate the witness. So from the witness, the backend is going to generate the proof. So here you can see we are generating an input that takes two parameters, the public and the private parameters, using the execute function on the Nova, which is going to produce the witness. So honk or the backend is going to use this witness to generate the proof, and this proof is being encoded and then returned to the test script where we are using the proof. Here you can see we are returning the proof and then passing to the parameter, the function parameters. On the blockchain, we are calling the verify functions that's been generated from this Nova programming language circuit. Right now, what I'm going to do is I'm going to execute few commands, and then we'll check whether we could verify it or not. Right. So before that, I'm going to delete this target folder. I don't no longer need it. I will do it from the start. First, I need to before that, when you run the Nova check, it produces the prover.toml where you have to fill the parameters. I have already filled the sulfur content is 30 and the limit is 50. So 30 is less than 50, so it should pass. If I go back to the readme, now I'm going to execute this execute function. Will both produce the bytecode as well as the witness. This witness is generated from the bytecode as well as the input parameters that we have given in the prover.toml. So as you can see, both the circuit is compiled and then the witness is also generated inside the target folder. We have two files. Now we are going to create a witness. We have already created the witness. We are going to create the verification key from the bytecode that's inside the circuit.json. So I'm going to paste this. I'll click enter. So I need to change the name of the file is going to be circuit, and I'm going to copy this and paste it over here. So now you can see the VK, the verification key, and the verification key hash being generated. What is the next step? So we have to produce the proof. Before that, I need to change the name, produce the proof. I'm going to change the name and copy this. The proof takes both the bytes as well as the witness. I'm going to paste this. This is going to generate a proof inside the target folder. You can see the proof is being generated over here. Got it? Now we're going to verify using this function. So the verify function takes the verification key that we have already generated and then the proof that we have generated right now. So I'm going to paste this. So this should pass. Let's see. So here you can see the proof verified successfully. We have successfully verified that the sulfur content is within the limits without revealing the actual sulfur content. So if I want, I could also show you the test script. As I said before, we get the proof and then we run this and check the after state. Once after this function is updated, we get the node using the get node. It's a getter function and check if the state has been updated to the nominator, and also we check the IMO and the supplier ID. If you want to go, we can also check the nomination. Actually, delivery ID is the input. Okay, that's fine. And this should revert y because the threshold is 50 but the actual sulfur is 60. So when we create the proof, it should fail. Why? Because here the threshold is 50 but the actual sulfur is 60. So 60 is not less than 50, right? So this fails. And if you want, I can also show you the test for the Meriton registry test. It's very simple test. Admin, as I told before, the admin registers the ship and then the supplier from the IMO and then the supplier ID. We already create the chief engineers and supplier as an address using the make ADDR or create wallet. So yeah, so vm.wallet, create wallet, and then the supply, we prank the supplier and calls the nominate function, and these are the parameters: the final destination, final density, final quantity, and the sample ID, which is required for calling the finalize function, and also to generate the signatures. So delivery ID, IMO, supplier ID, final density, quantity, sulfur, and then the sample ID. All of these are encoded. We get the message hash. From the message hash we get the each signed message hash. This is the digest what we're going to sign, and using the private key that we have created using the create wallet, we're going to generate the signature. Make sure you encode it properly, like it produces the BRS, but you're going to encode it as RSV, and then do the same for the chief engineers and pass it into this function, and this should update the uh, uh, this update the status. So you can see over here when I call the get node, it updates the status to the finalist. VM.expect revert. So this should be called only by the admin of the contract or the owner of the contract. So if the chief engineer calls, it's going to revert, and after that you can see like the admin calls this function, it passes, and it also emits the delivery ID and then the mock PDF hash. And this delivery ID is the only index, so the first parameter is true and then false true, and then we check the status has been updated to the quantums, and also the PDF and then the quantum signatures have been updated. This is the same thing, but again if an admin tries to call the anchor quantum seal, it's going to revert because the bunker is not finalized. That's one thing. Yeah, so here we are missing a step, so we have to call the finalized function, so which is missing inside the quantum resistance. So there is a check here, it requires it should be finalized, which has been updated inside the finalized bunker mode function inside the contract. So hopefully it's clear. It's a bit advanced, but I can show you I can share you the GitHub repo where you can go through it. So yeah, and finally you got the answer for this. Why do we need the zero knowledge for zero knowledge for the complaints? So to prove the port authority, that the sulfur content is less than the constraint without revealing the actual sulfur content. So this is not just for the sulfur content, you can also use it for other criterias. For example, flash point, the fuel temperature should be less than or greater than a certain temperature. So we can use it for all other complaints. I hope this video provides a knowledge about like how to use zero knowledge. Like yeah, like more than that, you need to find the perfect use case. That's very important. So thank you. I think I'm going to end the live over here. I don't know how long it took. So it's been 17-18 minutes. Okay, it's already been 1 o'clock, so I'm going to sleep now. Thank you for watching, and see you on the next video.